Mark P. Otten back with you. All right, welcome to your multiple group model in R video for structural equation modeling. I just watched my multiple group model PowerPoint video. I just watched it back and I feel like I did not project enough energy and excitement and gratitude for what these computers and what these methods do for us. I feel like if even one of the researchers of this 30, 40 years ago were to watch the video that you're about to watch on R and see the amount of math that goes into a multiple group model, then play out in a computer program in 2 seconds. These people would be falling out of their chairs with the advancements that we've made with our technology. So with that, let's show you what we can do with R. So, okay, so I have brought back my basketball performance and anxiety structural equation model here for the purposes of this example. And I have added in a gender variable as our grouping variable, 1 female and 2 male. And then we've got the triangle here, the constant predicting basketball performance, which we could look at as we could compare the mean of basketball performance for females versus males. I'm not going to do that. I don't want judgment based on like, oh, Dr. Otten thinks that one gender is better than the other at basketball. So we're not going to do that. But we're going to do everything else that goes into a multiple group model. The multiple group model here, we just start out by adding a couple of things and running it without any constraints, as we talk about constraints here in this video. So first of all, I imported the data with gender here as the additional variable. It's the same data I've used in a past video or two. And the gender variable needed to be a string variable for this to work in SPSS. So you designate it as a string variable first, and then as opposed to numeric. For some reason, that triggers R to allow a multiple group model to happen based on this group membership variable. So anyway, in this case, like I said, females 1, males 2. And then we've got our model set up from before. This is the same model that we ran in the past in a video. And we've also pretty much got the same fit statements here, as well as modification indices code here. So there's just a couple of different variations here that allow us to start the multiple group process. So the first one is typing in mean structure equals T into your fit statement there, or your syntax. By the way, I'm running this as a SEM. If you are running this as, let's say, a CFA, the additions here are going to be the same. This mean structure equals T statement goes into the same location right after your data statement. Data equals, in this case, my data is called multiple group or multi-group with a capital M. Mean structure equals T, that inserts in our constant here to allow us to compare means of latent variables if we want, which for this particular video we will not, but we could if we wanted. Compare gender means. And then the other thing that's new here is group equals gender, gender in quotes, and gender is the name of the variable, the grouping variable in my data set. So just watch out for capital letters. If it's capital G there, make sure that's a capital G. Mine is lowercase. And then this summary statement below to get our fit statistics and all of our standardized values, that's the same as it was before. So I'm going to go ahead and run this. It's going to give us a bunch of stuff, a bunch of familiar stuff, but it's going to have 2 sections now. This is group 2 and then all the stuff. And then we have group 1 above it and all the stuff. So it's got 2 rounds of stuff, which is cool. And then it's got 1 combined chi-square test statistic here and set of fit indices. So in this case, we have a chi-square of 181.897 that applies to both males and females. Now we're looking at this model across both genders. And we're not yet comparing directly, but we are testing for fit. And so we've got a comparative fit index CFI 0.93. But this is just step 1. So if we look at the steps here, we're going to jot down the 181.897, that value, the degrees of freedom as well. And then we're going to start adding some constraints to the model and to see what happens. So I'm not going to do much right now with this until the constraint situation is settled, and then we can proceed with further interpretation. So to add these constraints, so I've got this line down here, these two lines down here at the bottom. This is the syntax that you would use if you were applying all constraints, factor loadings, factor variances and covariances and regression coefficients and residuals. That's if everything's constrained. But as you know from the other video that I posted, we got to do this one step at a time. So I'm going to put just the loadings in there at first. So I'm going to grab this first part, and it's going to go in here after group equals gender. So I'm going to put a comma, and then I'm going to hit enter to go to the next line just so you can see it better. You don't have to do that. And then I'm going to paste this guy in, and there's two parentheses at the end there. Group dot equal equals C, and then that's C for constraints, and then loadings in quotes. That's going to constrain our factor loadings only, and for this particular model, it is the loadings corresponding to our 4 latent variables here. You can see. And then we will compare our chi-square to what it looked like before I added that in. So I'm going to highlight this again and run. I'm going to get a whole new set of stuff. Again, 2 sets of results, one for males and one for females. And then you've got your chi-square here, which I have made some notes on. So your chi-square is 188.296 now with 104 degrees of freedom. And so if you look over here, you might start jotting these down if you're going along in your homework or in your project. So this was what we had before. Now this is what we have here with the loadings constraints, setting the loadings equal to each other and asking the computer, hey, is that okay? Like, are males and females approximately equal on these factor loadings? And in this case, the answer is yes, they are approximately equal. We know that because, okay, so I subtracted 181.897 from 188, the new chi-square, to get 6.399. And then I saw that it was 104 degrees of freedom instead of 96. So there's been a change of 8 degrees of freedom. And if you look at the model again, the way you can decipher that, there's 8 degrees of freedom it's been constrained now. And so what R has done is constrained 2 out of the 3 items for each particular latent variable. And when we originally set this model up, we set, like, item 2 was set to 1 as a marker variable for cognitive anxiety. Item 3 was set to 1 as a marker variable for self-confidence, and so on. So each latent variable has 1 item out of the 3 that is set to 1. Therefore, it's already set to something, so we can't constrain it. Or if we did, it wouldn't be interesting because everything in for both females and males, that value is 1 each time. So those were R knew somehow magically, R knew to leave those out when it was constraining factor loadings. And it constrained the rest. It constrained item 5, item 8, item 7, item 9, and so on, the factor loadings 2 per variable that are being estimated by the model. So 4 latent variables, 2 loadings per variable comes to 8 degrees of freedom, or 8 loadings now being constrained. And what happened? Well, when we subtracted these chi-square values, we got 6.399. With 8 degrees of freedom, your chi-square critical value is 15.51. I got that from just this standard chi-square table here. Trying to highlight that. There you go. 15.51, 8 degrees of freedom, alpha 0.05. So that's your critical value, your cutoff point. So this chi-square 6.399 would have had to be greater than that 15.51 in order to say, stop, there's group differences here. In this case, the chi-square didn't change as much or enough to say there's group differences. So we constrained them. Males and females we're now saying that males and females are equal or can be constrained. The loadings can be constrained, and we're not losing value in our model. And so we should constrain them if we're looking at a multiple group model. Okay, so we have constrained successfully our factor loadings, and we can move on to step 2. Step 2 is factor variances and covariances. So if we're looking back at R, we just need to add these next two here. LV stands for latent variable. So I'm going to plug these in after a comma into our constraint statement. And after the load, so we're still constraining the loadings. Now we're constraining the variances and covariances. In this case, it's like one variance per latent variable. So there's going to be 4 of those, and then we have 3 covariances. So it should be a 7 degrees of freedom change. 4 variances, 3 covariances. If we are doing this right, hopefully it comes out that way. Let's see. I did play test this earlier, so it should work. Okay, so we scroll back up to the top of the new output. Again, you get a 192.83, which is your new chi-square. Degrees of freedom 111. It was a change of 7 here. Degrees of freedom from 104 to 111. So it was 4 variances, 3 covariances for this particular model. Chi-square difference, when you subtract 192.83 minus 188.296, you get 4.534. With 7 degrees of freedom, your critical value from the table, 14.07. Again, same result. We constrained the factor variances and covariances, and we were successful in the sense that they are equal or approximately equal across groups. So we can keep going. And so there's the next step coming up here again. Step 3 is the regression coefficients. So I'm going to add in one more here to our constraint list. It's getting longer. Regressions looks good. Okay, so let's run this one more time with those. Scroll back up for the chi-square. New chi-square 193.01. That's a tiny change. You subtract that, it's 0.18. 193.01 minus 192.83. Tiny change, so very little effect there. Very little effect on the chi-square when you constrain those 3 regression coefficients. I think it's 3. 1, 2, 3. It's just these 3 latent variables predicting basketball performance. That's what's been constrained across men and women, males and females. Okay, so 3 degrees of freedom is the change. 114 minus 111. Chi-square critical value drops to 7.81, but we're still way below that. So we've constrained now 3 times, and each time R is telling us that's fine. And these, there is no difference across males and females in terms of anxiety influencing performance in this case. So what else can we do? Well, there's a couple other things we can do. One is constrain the residuals. That's in here as well. I'm not going to do that because it's not typically recommended to go that far in your constraints. By now we have figured out that, like, if I were doing this in real life, I'd be like, man, I should not have separated males and females in this way. Let's go back to a model that applies to both, because they don't seem to be having a different pattern in this case in the data set. So I would stop and do that, say that, instead of constraining residuals to be equal. Not much of a point, but you could do it. You would just add it in as an additional statement there in the group.equal statement. And then I should mention this mod indices line. This is the LM test, and I talk about the LM test in the video on multiple group models. It comes into play when you have the other situation. Let's say we had constrained some stuff and the chi-square changed a bunch, and now we're like, oh, we should stop and figure out what the differences are across groups. That's usually interesting, right? Like, oh, let's say hypothetically in this case, we constrained the regression coefficients and it didn't work. Well, that would mean that maybe cognitive anxiety is affecting basketball performance differently for males than for females. Maybe one is higher on that coefficient than the other. So that's cool. That would have been cool if that had happened. And if that happens, and we get that chi-square difference test, and they're showing a change in the chi-square, then we would go to this LM test here, or the mod indices command in R, to sort out what's going on, try to figure out what the change should be, and if all 3 of those regression coefficients are different across groups, or if just one of them is, And so that's where you would go to look for that stuff. So I'm not going to cover that here because we didn't have to. If you find yourself in this position when you're working on your homework, just let me know. I can help you run these additional tests and then interpret. So let's see. I think that's all I wanted to say for this video. I hope that was clear. Again, I just covered that in 15 minutes when people 30, 40 years ago were drawing equations on chalkboards and trying to figure this out. So thanks to the lots of gratitude to the computing wizards who have created these amazing computer programs in the last generation. So we will take advantage of those advances in technology and run these models and enjoy. And let me know what questions you have.